Now, under this Reasons Review Unit 2 of Congruence and Proving Properties of Parallelograms, we are exclusively focusing on proving properties of parallelograms. So, in this packet, you have first question. A parallelogram must be a rectangle. See, if you want to say this parallelogram, a rectangle, diagonals are perpendicular. In the case of a rectangle, diagonals are not perpendicular, so this parallelogram also not necessary to perpendicular. That's a not correct reason. Diagonals are congruent. So in the case of a, before I go for this, opposite sides are parallel. Of course, in a parallelogram and in a rectangle, always the sides are parallel. Opposite sides are congruent. Also, not only they are parallel, these two are equal, these two are equal. Therefore, these are the not correct reasons. So, what is he saying? A parallelogram must be a rectangle when its diagonals are congruent. Actually, the difference between a rectangle, always the diagonals are equal. In the case of a parallelogram, this is very lengthier than this one. These two are not equal. When they are equal, then only that becomes rectangle. Therefore, diagonals are congruent is the main reason. Next, a rhombus must be a square when it's diagonal. Okay, one by one. See, this is a rhombus, whereas this is a square. What is the difference between rhombus and square? Diagonals are perpendicular. In both the figures, the diagonals are perpendicular. That means here it is 90, here it is 90. So this is not the specific reason. Next, diagonals are, opposite sides are parallel. Always these two sides are parallel to these two. I mean, this side is parallel to this and this side is parallel. In the same case, these two are parallel and these two are parallel. That is not any peculiar property. So, this is also not the reason. Opposite sides are congruent. Always all the four sides are equal here. All the four sides are equal in the case of a rhombus and also a square. Whereas diagonals are not equal. In the case of a square, they are equal. But in the case of a rhombus, this is very smaller. This is very lengthier. So when these two are not equal, then that's why it is different from the square. So when they are equal, then only this becomes square. Therefore, diagonals are congruent is the reason. Only when they equal, this rhombus becomes square. That's how you have to answer. Next, a quadrilateral is not a parallelogram. See, you can take any quadrilateral. This quadrilateral becomes parallelogram when the opposite sides are congruent. When the opposite sides are congruent, automatically it becomes parallelogram. But it is not a parallelogram, he is saying. That's why this is not the reason. And opposite sides are parallel. If opposite sides are parallel, automatically this is a parallelogram. But a quadrilateral is not a parallelogram, he is saying. So this is also not the required reason. Next, opposite angles are congruent. Always this angle equal to this angle and this angle is equal to this angle. That means these two are opposite, they are equal. These two are opposite, they are equal. Therefore, this quadrilateral becomes parallelogram. But he is saying this is not a parallelogram. That's why this is not the reason. Therefore, diagonals do not bisect each other. In the case of a quadrilateral, if the diagonals do not bisect each other. In the case of a parallelogram, they bisect each other. But he is saying when they are not bisecting means definitely this quadrilateral is not a parallelogram. So this is the correct reason. In this way, you have to judge using the properties. And let's go for fourth and fifth. Both are same type. This fourth and fifth. I do fourth one. You can do in the same way the fifth one. So what is it saying? In a parallelogram QRST shown below, diagonal TR is drawn. And U and V are points. These U and V are points on TS and in this QR, on this QR respectively. And UV intersects, this UV intersecting TR at W. So measure of angle S, this is 60 degrees. SRT, where is SRT? SRT, this angle is 83 degrees. And TWU, TWU. This is 35 degrees. What is WVQ? WVQ. That means he is asking about this angle. See how I am proceeding. In the case of, since he is saying QRST is a parallelogram, QRST, this angle, if it is 60, this must be 60 because opposite angles are equal. When this is 60, since this side is parallel to this side, this is a transversal, this angle and this total angle. This angle are same sided interior angles. Their sum is 180. Therefore, this 60, if you subtract from 180, you will get 120. So 120 degrees is here, this total angle. If this is 120, this must be 120. But already we know this red angle is 83. So from 120, if I subtract this 83, I will get 37 degrees here. This angle is 37. It is here. But here they have given us 35. Since this is vertically opposite to this is also 35. So if you take this W or V, this is 35 and this is 37. You add them up, you get 72. These two angles sum is this exterior angle. That is what we want, WVQ. Therefore, measure of WVQ is 72. Why I am writing directly this is sum? Because some of the interior angles is exactly equal to the exterior angle. That's why. So if you do not understand, you can watch this video again and again. You can understand better. That facility is here. That is why this is the video. Next, go to fifth one. After understanding 4, you try yourself. Fifth one, you get the answer. I don't know how much is the answer. You have to find out in the same exact way. Next, let's go for last question in this video. Sixth one. Quadrilateral ABCD has diagonals AC and BD. I can draw one quadrilateral so that I can understand better. ABCD, AC and BD are diagonals. This is only quadrilateral. Which information is not sufficient to prove ABCD is a parallelogram? See, AC and BD bisect each other. We know AC and BD bisect. If they bisect, definitely that is a parallelogram. But he is saying not ABCD a parallelogram. That's why this is not the required answer. AB is CD. This AB and CD opposite sides are equal. BC and ED, they are also equal. When they are equal, automatically it becomes parallelogram. But we want not parallelogram. That's why this is not the answer. AB is CD. That means these two sides are equal. Also AB is parallel to CD. They are not only equal but also parallel. When one pair of sides both equal and parallel, that is nothing but a parallelogram. But this is a sufficient region. This is like these two. This is also a sufficient region. But we want not sufficient reason. Therefore, AB is equal to CD. They are equal. And BC is parallel to AD. They are not related and it's not sufficient to say ABCD is a parallelogram. That's why this is the answer for this sixth question. Thank you.